If you've ever picked up a paint color chip and flipped to the back side, it probably says the name of the color code, and often also something that says light reflectance value. Most people will probably never pay attention to this number, but if you're a curious individual, which I assume most of you watching this video are, you might wonder, what does this number mean and what is it used for? Light reflectance value is a measurement of the amount of visible light when illuminated by a light source that's reflected by a surface in all directions and all wavelengths. It's a value that's generally used by interior designers, lighting designers, and architects to determine what is the most appropriate color to use on a surface. Of course, it's not the only factor that matters in color selection, but it is one of the most important, yet also often overlooked aspect of design. Light reflectance value not only affects how light or dark a space looks and feels, it also dramatically affects the performance of lighting sources, the ability to reflect and absorb natural daylight, the energy efficiency of the building, as well as accessibility for people with visual impairments. To understand how light reflectance value works, we first have to be clear about what the word value means in the context of color. There are three main properties of color: hue, saturation, and value. Hue is the classification of color on the spectrum. These are your reds, blues, greens, oranges, yellows, etc. While hue is generally important in determining the aesthetic feeling of the space, to someone with color blindness, they may not see a difference between colors of different hues. Saturation is the intensity of the color, how dull or muted a color looks versus how intense or vivid it is. Saturation is often confused with value, as it may seem like an intense color is brighter than a dull color. But saturated colors vary in value and often can be very dark when it comes to the amount of light it actually reflects. Light reflectance value is expressed from 0 to 100. 0 means the color absorbs all the light and reflects nothing. 100 would reflect 100% of the light. In everyday reality though, nothing will absorb all the light. I mean, unless your wall is like a black hole, but that would be a big problem. Even the darkest paint will usually have an LRV of about 3 to 4, and generally the highest LRV you'll see are in the low 90s. A designer will evaluate what is the functional requirement of the space, how much access is there to windows and natural light, what lighting fixtures are used in the space, what is the energy requirement of the project, and use these factors to determine what is the appropriate LRV each surface needs to have. So lights come in varying levels of lumen output, but how much of the light emitted from a source ultimately ends up being usable depends on a lot of different factors. One of these factors is how reflective the surrounding environment is. A room, especially the ceiling that's painted in low LRV colors, will dramatically reduce the amount of light that's in the space. Some environments require higher light levels than others. For example, a designer will typically specify ceiling LRVs of 85 or more and wall LRVs of 70 or more for office environments where detailed tasks are being performed. In a boutique retail shop or nightclub, lower LRVs may be used to achieve a darker, more intimate atmosphere. However, the designer will still need to ensure that the light levels are appropriate for employees to perform their tasks and for everyone to get around safely. In most commercial projects, an interior designer will coordinate LRVs with a lighting designer, who will carry out lighting calculations and other photometric assessments in order to develop a lighting plan that achieves required light levels. Some property owners and/or municipalities may also have energy requirements, such as wattage restrictions on artificial lighting or requiring the use of daylighting. In this case, increasing the LRVs of ceilings and vertical surfaces may be needed to maximize the reflectance of natural light and reduce the amount of artificial lighting needed for the occupants to safely and effectively perform their tasks. After all, it's literally a sustainability strategy that costs nothing. Designers also use LRV to design spaces that are inclusive of people with disabilities. Contrary to popular belief, most blind people have some level of vision, but many will have trouble distinguishing one surface from another if their values are too similar. Thus, using high-value contrast between surfaces is crucial in ensuring occupants can get around safely and efficiently. For example, handrails, stair nosings, start of ramps, edge of platforms, and signage graphics should have a high level of contrast against their surroundings to be visually apparent to the viewer. Most accessibility standards recommend a 70% contrast for these locations. This is the formula for calculating 70% contrast. While in most places it's only a recommendation, in some locations, such as in detectable warning surfaces in California, it's a mandatory building code requirement. It's important to remember that these design decisions not only help blind people, it makes the environment more accessible for everyone, including nearsighted people like me when I'm not wearing my contacts or glasses, or any person in low light conditions, such as during a power outage when only the emergency lights are on. In my many years of being a designer, I've definitely heard people joke about how all we do is pick colors, and honestly, I don't take it as an insult. While it's obviously far from all that we do, choosing the right color is a really important job. It affects the environmental experience of the space, contributes to human comfort, influences energy efficiency, and is crucial in ensuring safety and accessibility. Thanks for watching, everyone. If you like this video, here are some more like it that you can check out. And don't forget to subscribe for more to come. Bye for now.